So welcome to your own YouTube channel, Sarzan. So today we are going to talk about the electric field. So what is basically the electric field and what is the basic concept of the electric field? And after that electric field, we will talk about the electric field intensity. Okay, so let us start. We will start with the definition of the electric field. So, electric field is basically the area around any charge in which it exerts the force on a unit positive charge. Okay, so let me explain it. So, I will take a charge. Let's say, okay, let me change the color. Let's say it is a charge. Okay, and this charge, and there is another charge here. This charge. Okay, let's say this charge here, it is q1 and it is a positive charge, and let's say this charge here is q2. Okay, and it is a negative charge. So in the case of the positive charge, the electric field lines originate from the positive charge and move away in this way. So these are the electric field lines. Okay, and in the case of the negative charge, the electric field lines move towards the negative charge. So it is a convention. So in this, it will move towards, and towards. Okay. So coming to back towards our basic topic. So what is electric field? So it is the area. So let's say the electric field lines are going towards this extent. So this is the area. So let's say I have a charge here and one charge here, and both are these negative charge. Both are these negative charge. Okay. So now if we see that, what will happen when when this if we talk about this negative charge, it is present in the area, in the region where the electric field lines are present. Okay, so what will happen, this positive charge will attract this negative charge towards itself. Okay, it will exert a force and it will exert this negative charge towards itself because it is present in the area in which the positive charge can exert the negative charge, the force on the negative charge. So let's say we have another charge, this charge. Okay, so what will happen, because this charge is outside the area of the influence of this charge, so what will happen, this charge, this positive charge, will not exert any force on this negative charge. Okay, so in small word we can say that this positive charge can exert the force up to this, up to here. Okay, up to here, here and here. If any charge is present beside or beyond this area of influence where it can exert force, it can't exert any force. So we can say that the area around any charge in which it can exert a force on a specific charge. Here I have taken the unit positive charge, but we can also take the negative charge. Okay, so it is basically the area around any charge in which any charge exert a force on another charge. Okay, if this charge cannot exert a force in this charge, it means that this charge is outside the electric field of this positive charge. Okay, similarly if we go towards the electric field intensity, so what is the electric field intensity? It is the force exerted by a charge on a unit positive charge in its electric field. Okay, so let us take an example. Let's say I have a charge here and it is my q charge. I will take it as q charge q1. Okay, and it is a, I will take it as a negative charge. Okay, so what will happen, according to our previous concept, the electric field lines will come towards it because it is our negative charge. So the lines will move towards it. Okay, so it is basically the electric field, the area around the charge in which it can influence or attract or repel the other charge. Okay, so let me raise this. Okay, so it is a field here. Okay, so let's say I have a unit positive charge, because in this in this we can say that definition I have taken the unit positive charge. So I will take a charge. So basically first we have to understand that what is a unit positive charge. So we can say a charge, positive charge of 1 coulomb. Okay, unity means 1, so unit positive charge is basically a charge, a positive charge of magnitude of 1 coulomb. Okay, so let me take another charge. Okay, this time I will take this charge here, okay, in the field, and this is my charge. It is this is my charge, and it is what, it is a q2 charge, and it is a positive charge. It is a positive charge. So what will happen, this q1 will exert a force, and will try to attract this positive charge. So it will try to attract this positive charge towards itself. So what is the electric field intensity? It is basically the force, the force the force exerted by a charge in its field on a unit positive charge. So in a small way, in a brief way, or in an easy way, we can also say that the electric field intensity is basically force per unit charge, F over Q. So it is the formula of what, of the electric field intensity. Okay, so if we take it further, we'll further dig upon it. So as we know that electric field intensity is equal to force per unit charge. Okay, okay, good. Okay, if we remember from the Coulomb's law, we know that the force is equal to what, is it is equal to K into Q1 into Q2 over R square. So what we will do, we will put this force, value of this force in here, and what will we get? We will get electric field equal to K Q1 into Q2 over R square into Q. Okay, so if we go there, what is this charge? This charge here is my Q2. So the force is exerting on which charge? On Q2 charge. But if we go, it is a general formula, and in this our case, on which the force is acting, it is acting on a unit positive charge, and we've taken it as Q2. So I will put Q2 here. So this charge, basically this charge here, it is what, it is Q2. Okay, so I will take this charge as Q2. Okay, so this is Q2. So Q2 will cancel out with this Q2, and the electric field intensity is basically equal to K into Q1 into Q2 over, no, wait, Q2 has been eliminated, so there will no be Q2. Okay, there will no Q2. In fact, it is equal to K into Q1 into Q2. So move the Q2, and it is equal to R square. So this is what, this is the formula of electric field intensity. Okay, so this is the formula. It is a general formula, and we dig upon, so it is the more elaborated formula of the electric field intensity. So now moving towards, what is the unit, what is basically the unit of the electric field intensity. So it is very easy, we calculate it now. Electric field intensity is equal to force per unit charge. Okay, so we know that the formula, the unit of the force is Newton. We all know that is Newton, but in the scientist, because he invented force, so that's why the unit of the force is Newton, and of the charge is Coulomb. So electric field is equal to Newton per Coulomb. So it is the unit of the electric field intensity. So what is basically, now we will dig upon further. So what is electric field intensity? Is it scalar, or is it a vector? So remember one thing, because in the electric field intensity we have force here, so you can remember this way. That's why electric field intensity is a vector quantity. So what is it? It is a vector quantity. So I will put a sign here. So electric field intensity is basically a vector quantity. So it was a lecture. Thank you very much. We will meet again.